Welcome to solverfy, the place where learning becomes simple. If you're struggling with homework, assignment, or doubt in subjects, don't worry, you are in the right place.
For this problem, we're going to use the law of cosines. So go ahead and write that out. So 0.6 squared is equal to xa squared plus 0.2 squared minus 2xa. I'm going to multiply that by 0.2 and multiply that by the cosine of our angle. So that's our law of cosines. We can go ahead and rewrite this to we want to get our delta xa in there, and we also want to have it be solved for delta xa. So if we do that, we end up with the equation delta xa is equal to 0.4 xa times the sine of the angle, and that's going to be over top of 0.4 times the cosine of the angle, and then we're going to subtract 2xa. So that's one of our equations we're going to use. So when the flywheel undergoes positive angular displacement, both the force and the couple moment are going to do negative work. So knowing that, we go down here and here. So we know that our delta U is equal to 0. So our equation that we'll need, since it's doing negative work, will be negative force times delta xa, and then minus the couple moment times angular displacement is 0. So those are the two equations that we will need. So now we can substitute in our first equation right here that we figured out into the second one. So if we do that, we end up with the equation make sure we got plenty of room here. So on top we have 0.4 xa times the sine of the angle, and then on the bottom we have 0.4 cosine of the angle minus 2xa. We're going to multiply that by the force, and we're going to add the couple moment, and we're going to multiply that whole thing by angular displacement is 0. So since we know that our angular displacement does not equal 0, we can do this problem without this part. We can kind of X it out. So if we take that part out and we rewrite but solve for the force, we end up with F is equal to the negative couple moment, and then in the parentheses it will be switched, so we will have 0.4 cosine of the angle minus 2xa, and on the bottom we will have 0.4 xa times the sine of the angle. Done. So we also know that our couple moment is 75, so we can erase our variable there and put in 75. So if we go ahead and use this equation, we can end up with a plot on a graph. So if we scroll down here, I've already drawn out our coordinates. So we were supposed to do from 0 to 180 degrees, which is the top line here. And we can fit those numbers in to this equation right here and figure out the other numbers for this graph. So if we were going to go ahead and graph them, we have, starting at the top left, or actually we can start at the apex, which we have at the very end here, is 73. And 73 corresponds to about 356 So it would be about here. We'll draw that point. And then we can just use these numbers to kind of fill in the rest of the points as best that we can. Obviously, this graph is not perfect as it's hand-drawn, but we just need to use this table over here that we figured out from filling in the numbers from 0 to 180, as the question stated, to just put in our numbers. And along the bottom here, we have our angle, and along the top here, we have our force. So we end up with a line like that.